Assalamu alaikum, this is Gr10. Today I'll continue explaining what we have learned in the previous session about determining the position of an element in the periodic table. At the end of this session, you will be able to determine the location of an element in the periodic table according to Gr10 and identify the different blocks of the modern periodic table. So please prepare your pen and your chemistry booklet. Up till now, we've ended up by the conclusion that the electron configurations of the elements in column 1 end by S1, while the electron configurations of the elements in column 2 end by S2. But what about other elements in the periodic table? How do their electron configurations end? Let's start with the transition elements. Remember that transition elements are the elements located in columns 3 till 12. Begin with column 3. Write the electron configuration of the following elements in column 3, Sc with atomic number 21 and Y with atomic number 39. These are the corresponding electron configurations of the mentioned elements. Now listen to the question. How does the electron configuration of each element in column 3 end? As you can see, the electron configurations of both elements end by D1. So what can you deduce? We notice that the electron configurations of the elements in column 3 end by D1. Now consider the electron configuration of an element in each of the following columns. Focus on how does the electron configuration of the element in column 4 end. Right, it ends by D2. And therefore, the electron configurations of all elements in column 4 end by D2. Same question. How does the electron configuration of the element in column 5 end? As you can see, it ends by D3, and this is the case for all elements in column 5. Similarly, the electron configuration of the element in column 6 ends by D4, and that of column 7, it ends by D5. Now, can you guess how does the electron configuration end in other transition elements? Exactly. The electron configurations of the elements in column 8 end by D6, and that of column 9, they end by D7, while the electron configurations of the elements in column 10 end by D8, and that of column 11, they end by D9. So the electron configurations of the elements in column 12 must end by D10. So what is the relation between the electron configurations of transition elements and the column to which these elements belong? As a conclusion, the electron configurations of transition elements or elements from columns 3 till 12 end by the column -2. Let's take an example. If an element belongs to column 5, its electron configuration must end by D5-2, which is D3. Now reverse the situation. If the electron configuration of an element ends by D, the column is the electron on D+2. If, for example, an element's electron configuration ends by D6, the element must belong to column 8. Now move to the periodic table. Why do you think we add 2 to the electrons on D sublevel to find the column to which a transition element belongs? Simply because transition elements start from column 3 and they are preceded by 2 columns. So the electron configuration of the first transition element ends by D1, and the electron configuration of the last transition element ends by D10. Now evaluate yourselves through this application. Determine the column, period, and family to which the element Fe belongs. Pause the video and think for a while. As usual, you are given the atomic number, which is 26, so the number of electrons in Fe is 26. Thus, the electron configuration of Fe is as follows. As you can see, the highest energy level in Fe is 4, so Fe is in row 4 or period 4 since it has 4 energy levels. On the other hand, the electron configuration of Fe ends by D6, so it belongs to column 8, since the column is the electrons on d plus 2. And since Fe is in column 8, so it belongs to a family called the transition elements. Now move to the second part. Write the electron configuration of an element in column 11 and row 5. Pause the video again and write your answer on a draft. The element belongs to row 5, so it has 5 energy levels. It's also in column 11, so it's a transition element, since the transition elements belong to columns 3 till 12, and thus their electron configurations end by D. So the electron configuration of an element in column 11 must end by D9. Now let's write the electron configuration using Klichkowski diagram. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Pay attention, we can't stop right now since we are in row 4 and column 12, so we'll continue until we reach row 5. So 4p6, 5s2, also we can't stop although we reached row 5, but still we are not in column 11. So after 5s2 we have 4d, so we'll write 4d9. In this case, the element is in column 11 since the column is the electrons on d plus 2, and it's in row 5 since the highest energy level is 5. Remember that the electron configuration of transition elements always end by D. Till now, we knew that the electron configurations of transition elements end by D. Still we have elements in columns 13 till 18. Let's check how do their electron configurations end. Begin with column 13. Write the electron configurations of the following elements in column 13. Here is the corresponding electron configurations of both elements. Now, how does the electron configuration of each element in column 13 end? As you can see, the electron configurations of both elements end by P1. And therefore, the electron configurations of elements in column 13 end by P1. Now let's check how do the electron configurations of the elements in column 14, 15, 16, and 17 end. Here is an example of an element in each column. As you can see, the electron configuration of the element in column 14 ends by P2, while the electron configuration of the element in column 15 ends by P3, and that of column 16 it ends by P4, whereas the electron configuration of the element in column 17 ends by P5. Now, how do the electron configurations of the elements in column 18 end? The electron configurations of the elements in column 18 end by P6, except helium, its electron configuration ends by S2. In general, the electron configuration of the elements in column 13 till 18 end by P column minus 12, except the electron configuration of helium, which ends by S2. If, for example, an element belongs to column 17, its electron configuration must end by P column minus 12, so 17 minus 12, it must end by P5. Now reverse the situation. If the electron configuration of the element ends by P, the column is electrons on P plus 12. For example, if an element's electron configuration ends by P3, the element must belong to column 3 plus 12, so column 15. Now determine the location of an element X in the periodic table which has the following electron configuration. Once you are asked about the location, this means the column and the row. So by referring to the electron configuration, we can notice that X has 5 energy levels. So it belongs to row 5 or period 5 since it has 5 energy levels. Also, its electron configuration ends by P2. So X belongs to column 14 since the column is the electrons on P plus 12, or group 4 since its electron configuration ends by P2. Another question, write the electron configuration of an element in column 15 and row 3. Pause the video and think of the question. As discussed previously, the row indicates the number of energy levels. So an element in row 3 has 3 energy levels. The element belongs to column 15, so its electron configuration must end by p. Since the electron configurations of the elements in columns 13 till 18 end by p except for helium, which ends by s2. And therefore the electron configuration of the element in column 15 must end by p column minus 12. So 15 minus 12, it must end by p3. Now using Klichkowski diagram, we start writing the electron configuration until we reach the third energy level as a first condition. Then make sure that the electron configuration ends by p3. So 1s2, 2s2, 2p6. Pay attention here, we can't stop, although we reached the p sublevel, but we are still in row 2 and not row 3. So continue until you reach the third energy level. 3s2, here also we can't stop, although we reached the third energy level, but we are in column 2 and not column 15. So continue writing the electron configuration until this electron configuration ends by p3. Now after 3s2 we have a 3p, we put 3 electrons on the p sublevel. In this case we reached column 15 and row 3. Keep in your mind that the electron configurations of the elements located in columns 13 till 18 end by p except for helium, which ends by s2. The periodic table is divided into 4 blocks. Block S, which corresponds to group 1 and 2 of the periodic table. The electron configurations of the elements that belong to block S end by S sublevel. Block D, which corresponds to transition elements. Their electron configurations end by D. Block P, which corresponds to groups 3 till 8, or columns 13 till 18, except helium, which belongs to block S. The electron configurations of all elements of the p block end by p sublevel. What about lanthanides and actinides? To which block do they belong? In fact, they correspond to F block, so their electron configurations end by F sublevel. It's discussed right now that both lanthanides and actinides are F block elements. Let's check how do their electron configurations end. Write the electron configuration of La and Pn. As you can see, both La and Pn are lanthanides. This is the corresponding electron configuration of La, and this electron configuration corresponds to Pn. Now, how do the electron configurations of lanthanides end? To which row do they belong? As you can see, both elements' electron configurations end by 4f, and they belong to row 6, since they have 6 energy levels. So in general, the electron configurations of lanthanides end by 4f. They belong to row 6. Now, write the electron configuration of AC and U. As you can see, both AC and U belong to actinides. These are the corresponding electron configurations of both elements. Same question. How do the electron configurations of actinides end? To which row do they belong? As you can see, the electron configuration of each element end by 5f, and they belong to row 7. So in general, the electron configurations of actinides end by 5f, and they belong to row 7. Now it's time to scan the conclusion alone. Now determine to which row and family the element EU with atomic number 63 belongs. Take your time to solve this question. As usual, you have to write this statement whenever you want to find the number of electrons from the atomic number Z. So this is the corresponding electron configuration of the element. As you can see, the highest energy level is 6, so the element has 6 energy levels, so it belongs to row 6. The electron configuration of the element ends by 4f, so it belongs to a family called lanthanides. Finally, it's time to summarize. The electron configurations of the elements in columns 1 and 2 end by S1 and S2 respectively. They constitute the S block. The electron configurations of the elements in columns 3 till 12 end by D column -2, from D1 till D10 respectively. These elements constitute the D block. The electron configurations of the elements in columns 13 till 18 end by P column -12, from P1 till P6 respectively, except helium, which belongs to S block. The electron configurations of lanthanides end by 4F, and they belong to row 6, while the electron configurations of actinides end by 5F, they belong to row 7. Both actinides and lanthanides form the F block. For the next session, please watch the video again and referring to worksheet 3 of your worksheet booklet, solve applications 1 and 2, read the properties of metals and nonmetals, memorize the facts related to blocks and families, and finally, memorize the summary sheet, page 12.